We're here at the MotoIQ garage with Lawson from AEM Electronics. Say hi, Lawson.
Hi, Lawson.
And we're here to cover this 350Z that one of our customers brought in. Now, he's a guy that does track days and stuff, and he had all kinds of analog gauges all over the inside of the car. And when you're driving around the track, it can all get pretty distracting when you're trying to monitor critical parameters. And you have to look here, have to look there, and all that. And you have the gauge pod, and like the old school way of mounting gauges, right? So what he wanted to do is to consolidate all the engine monitoring stuff into like one easy to see thing, and also to have the ability to do some data logging. So we guided him toward the AEM CD-5, like a race dash. It's easy to install, and it can data log. And well, I guess we're going to go look to see what it is, right, Lawson?
Yes, we are. Yeah, actually, I believe what you did with this was the CD-5, and the elements at the end, or the letters at the end, would be the L and the G. So that would be for logging and GPS. Our CD-5 and CD-7 carbon, we've got a lot of iterations. So the CD-5 is a 5-inch diagonal display, 800 by 480 resolution. The CD-7 is a 7-inch diagonal display, also 800 by 480 resolution. From there, you have options for just GPS, just logging, or GPS and logging. And then you also have another iteration that we call the flat, or it's a flat panel style display. So our original one comes with a shade hood over the LEDs, and it comes with 2 buttons on it that allows you to change pages, because it is multi-programmable, has multi-programmable pages. And then the other button would clear values. So if you have a timer, countdown timer, anything that you're going to clear a value on would be the right button. Any page changing would be executed via the left button. The flat panel doesn't have those buttons. It still has all the LEDs, but it's a little more compact. So if you have a tighter location, or you want to integrate it, say, into a hot rod or a street car, you can do that and build an enclosure around it to make it look really, really flush and tight. And then you run remote buttons to be able to clear values and change pages. To that end, the base dash, or our original dash, our CD-7s and CD-5s, also have inputs for those remote buttons. So you can either change them at the dash on the front of the display, or if you want to wire buttons out, you have the option to do that as well. So we build a lot of flexibility into the dash, so you can use it the way you want. We also provide a few different iterations. I know for this application, especially for a track day style car, I think he's going to be really happy with the CD-5, because he doesn't have to pull out his entire dash. It's a smaller, more compact profile. It's going to give him all the data he wants. He can spread it across 4 different pages. So if he wants diagnostics and a bunch of channels, like say when he starts the car, he can do that. And then when he's racing, he just wants to look at like gear, RPM, and speed. He can just put those channels on a page and focus on those elements as well.
And you can have another page for track mapping and stuff too, right?
Absolutely. Lap timing would be a perfect example of that. So because we have the GPS integrated into it, and of course the logging feature, but more importantly, the GPS allows you to create track maps and then do lap timing, not just live lap timing, but also predictive lap timing as well. So you can do your deltas, you can gauge whether you're going faster and slower based on predictive lap timing, and even pull up another page that we call an on-change page that would momentarily come up, show you your last lap, maybe give you your fastest and slowest lap, and you can actually have a gain-loss time on the display if you want in real time, that's predicting your lap time, your current lap time versus your best lap time.
And you can also monitor up to 22 channels of data?
On our 22-channel CAN sensor module. So the beauty of the CD carbon dashes are that they accept CAN inputs. And it's not exclusive to AEM Net CAN. So AEM Net would be our CAN bus network. A lot of manufacturers use CAN. Motec, Haltech, Holley, Big Stuff, all of them. What's really cool about our dashes is that we can communicate with all of those devices. So you don't just need our CAN module. If you have, for instance, a race grade 8-channel K-type thermocouple amplifier, you can import that CAN bus data into our dash. If you have race pack, shock position sensors, those output on CAN, and you can import that data. So what it allows you to do is really expand your channel set as you expand, what you want to see or what you want to record. You can start with just a little bit of data, but as your thirst for that data grows, or as you develop both as a driver and you want to develop the technical elements of your car, when you add those things, you're not going to have to upgrade ever again to get that data into your logger or onto your dash. We will accept almost all of it, like 99% of it. And in-house, we've tested over 200 non-AEM devices. And the stuff we haven't tested, we have the CAN data in our forum that's provided by the manufacturers. That's not just for aftermarket ECUs, loggers, and the like. That's also for like we accept OBD2 CAN for 2008 and up cars. So if you got an LS swap with an 08 and up engine, we can input the data from the stock ECU with no additional sensors. You connect it via our OBD2 CAN adapter, and you can bring that into your dash.
Now, if you have an older pre-2008 car, the box actually lets you plug in a bunch of analog inputs too, right?
That is where the CAN converter modules come into play, and we make a couple iterations of those. On this car, it has our 22-channel CAN sensor module. It's a really cool little box. You basically put 22 channels into it, and it transmits all 22 of those channels out over a 2-wire CAN bus connection to the dash. That allows you to get it a little bit closer to your sensors. It cleans up your wiring, and it makes it a lot easier to diagnose if you have any wiring issues as well.
And if you have like analog gauges already, and you want to use the sensors, you can use the CAN module to convert that signal to CAN also, right?
Yeah, if you have a gauge and it's got an analog output, you can run that output to an input in the CAN sensor module and then transmit that to the dash. And if you have our old if you have our X series gauges, we actually provide an AEM net CAN output on those gauges. So you can literally run the CAN directly to the dash from those gauges.
Now, I know like all this sounds like engineering babbling, but it's really cool. Like the CAN module allows you to simplify and clean everything up and integrate all your sensing, data logging, track mapping, and everything into one clean, compact display that's easy to use. It actually makes wiring and the installation of everything simpler. And shoot, are you ready to kind of walk through this thing on the car?
Yeah, absolutely. In fact, I brought somebody a lot smarter than me to walk you through the actual integration. I know that Howard's been busy getting everything wired up here, so I'm confident that it's all going to just push to the dash. So I'm going to please introduce Sam, have Sam come over. He's going to come up to the dash and open up Dash Design software and show you how easy it is to import this CAN, get it into a layout, and then spit that out onto the dash so that the vehicle owner can get out on the track and start using it.
Hi, I'm Sam with AEM Electronics. We are here today with MotoIQ setting up one of our CD-5 logging and GPS dash in this 350Z track car. We are using one of our 22-channel CAN sensor module to bring in all the analog channels in and stream it out via CAN to the dash. And we are also incorporating one of our inline X-series widebands to bring in AFR data as well. Today I'm going to cover how to make a channel and tie it to a gauge or a value. And then we're going to go and upload that up to the dash and make sure everything all works. All the dashes ship with a standard layout. They're not really specific for any specific vehicle, more catered towards our Infinity line of ECUs, so all the CAN setup and all the channel setup's already built for that. And I started off with one of these basic files, stripped out all the CAN data, and I'm gonna go and import a bunch of DBC files, which are basically all the CAN information built into files, and we have a whole assortment of DBC files from our products to other manufacturers, some OBD stuff, just everything we can. And then you just go through, select the DVC file for the product that you're using, select the channels that you want out of it, and then you'll go ahead and either tie that directly to a channel or a gauge or a data value, or create channels based off of that information. So what I have here is one of our basic layouts. I went ahead and stripped out a bunch of stuff that wasn't available because this is not being used with a standalone engine management system. And I also stripped out the whole CAN tab, so this is completely blank right now. So right now what I have is a couple screens with some channels that I've placed on the screen, but nothing is exactly tied to it, so they're not doing anything currently. Screen one I have as kind of a startup page to let the driver know if there's anything out of range, let them know that the temperatures are up to temp, and oil pressure is good and battery voltage is good. The second page is a driving page. Very simple. You got your mile per hour, you have your tach, and just some critical engine data. Page 3 is more of a driver page as well, but more for lap timing. Lets the driver know what his predicted lap times are, what his current lap times are, what his current lap is, which his fastest lap is, and how he's currently pacing versus his fastest lap. And page 4 is purely just lap timing. I've also incorporated a on-change page, which is the same as the lap timing page. What this will do is as each time the driver crosses the start-finish and the current lap increments, it will switch back to this page, let the driver know what his current times are and everything for 3 seconds, and then switch back to the previous page he was on. We're not going to get too far into that. We're just going to go into how to create a channel and tie it into a item on the screen. And we're going to go into the first page. We're going to start with the CAN tab. And since this is using one of our 22-channel CAN modules, I'm going to open up my documents. In there'll be a folder called AEM once you have the Dash Design 2.1 software installed. Within that, you'll find a Dash Design folder. And inside that, you'll have a folder called CAN. In here is where we have all of our DVC files for every single manufacturer, different ECUs, different products, anything that's CAN enabled, and we're constantly developing this. But right now, since we're using one of our 22-channel modules, the part number is 30-2212, CAN sensor module, and this will bring up this screen. You can actually stack 2 of these modules together to bring in a total of 42 channels maximum. Since we only have one module, I'm going to deselect module 2. And I'm only going to bring in the channels we need instead of everything. And per my notes, we have tach signal, fuel level signal, throttle position sensor on analog 1, oil pressure on analog 4, coolant temp on analog 9, and oil temp on analog 11. So I'm going to go and bring those channels in with 1, 4, 9, and 11. So we got 1, 4, 9, 11. We'll also bring in our tach signal, tach frequency, fuel level, and just for fun, let's stick in battery voltage. And just hit OK. And now we have all those CAN channels already brought in. You can see that the base units are all there, so the system's actually aware of the unit. So if something comes across as Celsius and you want to see it in Fahrenheit, you can switch that later. We'll also bring in our wideband, which is 0310, which allows us to bring a whole lot of them, but we only have one in the system, so we'll bring in series gauge 1. We'll bring in just the external wideband data. We don't need the rest of it. A lot of it's all diagnostic stuff. If you want to do a warning to let you know that your sensor is disconnected, you can do that, but for simplicity's sake, we're going to do just the wideband data. So now we have all our CAN channels in, and now we'll go and create some channels based off those CAN channels, because these CAN channels are coming across as ohms and voltages, which doesn't mean anything to the driver. We got to transfer these into actual values. So let's start with coolant temp. So we're going to create a new channel. We're going to call it coolant temp. And then we're going to tell it what channel to look at in CAN. And we have our coolant temp wired to analog 9. So the primary input, I'm going to select analog 9. This is using one of our temp sensors, and you can use our sensor library. So I'll select the sensor library, the category. I'm going to select temp fluid, The part number for the sensor is 30-2012. So I'm gonna select that there, and that's it. Now I have a coolant temp channel. Let's create an oil pressure channel. So the little plus sign here, channel name, I'll name it oil pressure. Oil pressure is wired into analog 4. So we'll select primary input. We'll select analog 4. We could use a sensor library for this as well. I'm going to show you how to use a transfer function. Since I know this sensor is our 0 to 150 psi oil pressure sensor, and I know that the voltage range for this sensor is 0.5 volts to 4.5 volts. So I'm going to select input 0.5 volts equals 0 psi, and then 4.5 volts equals 150 psi. And what I mean by you can select scalings or whatever you want, the units. So display units, I'm gonna go and select pressure. Where is that? Pressure gauge. And we're gonna go with PSI, pounds per square inch. So now that the system is aware of what that signal is, we can even convert it to kPa, bar, whatever you want. So we have those channels now. Let's go ahead and create a couple more channels for fuel level. Let's see, and engine RPM. Let's see, we'll create engine RPM. We'll call engine speed. And then the input for this will be CAN sensor module, tach frequency. This particular vehicle, we have the tach signal wired to the crank sensor signal, which is a 36-tooth crank sensor signal. So I figured out the frequency for that at 9,000 RPM, which this car probably will never see. The frequency for that is 5,400 hertz. So 5,400 hertz equals 9,000 RPM, and 0 hertz equals 0 RPM. And now we have an engine speed, and let's do fuel level for the last one. Fuel level, we'll select fuel level resistance. Where is that channel? Right there. Every vehicle is going to be different for fuel level. Per factory service manual on this car, I have 6 ohms of resistance across the fuel level sender when the system is full, and 123 ohms across the fuel level sender when the system is empty. This will probably be something you have to go and measure with an ohm meter. If you have that data, you could use that data. We have that data, so we're going to use it. So we're going to put 123 ohms as our input, and we're going to do our fuel level in a percentage value, so 0%, and then 6 ohms will be our 100%, and then we'll switch it over to percentage. And now we have our channels. And now we'll go ahead and tie these channels to the gauges on the screen. So for engine speed, right now it's not tied to anything. For input, we're going to select that engine RPM channel that we just created. And coolant temp, we're going to do the same thing. Select the coolant temp channel that we just created. And oil pressure, we'll do the same thing. And air-fuel ratio, just because that comes across natively over CAN. Some of you may notice that coolant temp is coming across on the input. It says Celsius, but we want Fahrenheit. Same thing for air-fuel ratio is coming across as lambda, but we want AFR gasoline. So we'll go back to the channels, and we'll select our AFR channel, and instead of showing up in lambda, we'll select AFR gasoline for display units. And then as well as coolant temp, which is showing in Celsius, we would want this in Fahrenheit. We'll select display units and select Fahrenheit. So now that changes it over to Fahrenheit and AFR gasoline. We're gonna go ahead and upload this to the dash and test it out and make sure everything's all working. You go ahead and wanna save a copy of it and then hit upload. When you select upload, there's actually a little checkbox here that says upload options to allow this file to be downloaded out of the dash. You can upload it this way so you can later on download the file back out and make changes to it if you want to, if you don't have a file, a version saved on your laptop. But if you're making something that you don't want someone else to be able to connect to and pull the file out, you would uncheck this box, which will make it not downloadable out of the dash. I'm just going to upload it that way so that it can be downloaded out. And hit upload. And now that we've uploaded it up to the dash, we can see everything's working. We have engine speed, 0 because the car is not running right now. Throttle position needs to be calibrated. I just set it at 0 voltage is 0% and 5 volt is 100%. Oil temp and coolant temp seems like it's working. Air-free ratio seems like it's working. Oil pressure seems like it's working, and battery volt seems good. On the driver page, we have the typical critical engine data. I'm gonna go over a little bit how to do a fuel gauge. What I did was created a simple bar graph, which can be done up here. You just select bar graph. I'm not gonna go too far into it, but it's a bar graph. I set the start at 0, end at 100, because it's gonna be a 0% to 100% fuel level. And I made the segment size at 12.5%, so I get a marker every eighth of a tank or so. I already went and created that fuel level channel previously, and what I did was went and tied this gauge to fuel level percent, and now we have a fuel level gauge. I'm gonna go ahead and tie the GPS speed also to GPS, and then tie the tach to engine speed as well. And then we're gonna go and save this and upload it to the dash. Hit the upload button. I'm gonna leave the selection to allow it to be downloaded out of the dash later. And I'll hit upload. Give it a moment. And once it says it's complete, we'll hit close, unplug, and everything should be there. So we have our startup page that shows just critical engine data before you actually go out and run. Hit the change page button once, and now we have our tach, our speed, our fuel level, and the critical engine data, as well as our GPS icon letting us know that the dash has a GPS lock as well. Up next, I'm going to cover alarms and warning messages, and what to do and how they work. Basically, we could set a bunch of channels and parameters that if any parameter gets above a certain threshold or below a threshold, or however way you want it to be, we can set it up so that it'll display a message across the bottom of the screen. And then if things get really bad, let's say coolant temp gets really high, we can have it go to the alarm page, which is a dedicated page to let the driver know that things are getting really, really bad. So there's actually 2 levels of warnings. You can have a simple warning where, hey, it's getting kind of hot, maybe check this out, maybe back off on it a little bit. And then if the driver doesn't do that or something really wrong and it gets really, really high, it'll switch over to an automatic warning page, bright red, lets you know that this is gonna die, probably want to pull off the track at this point. So we're gonna start off with creating an alarm, and that's done right here in the alarms tab. The difference between the alarms tab and warning messages, the messages actually are designed to display the message. The alarm is where you set the flag that if it's over this point, is where you set the logic that if this parameter gets over this number, trigger that alarm. And I'll set it up where we have 2 different levels, and we're gonna do one for coolant temp because I already have one for battery voltage that says that if battery voltage is below 11.5 volts above engine speed of 500 RPMs, then I'll allow that warning to happen. And we're gonna set 2 levels of coolant temp. I'm gonna do a warning level first. So I'm gonna call this warning coolant temp high, or just warning coolant temp, works fine. And then we're gonna select what channel to watch. And we're gonna select the coolant temp channel. And then we have a condition symbol. You have either less than, greater than, equal to, in between, less than and equal to, or greater than and equal to. And we're gonna just select if coolant temp is greater than, let's say 225. And so you can select the logic or nor, and we select engine speed, because I want this warning to only trigger if the engine's running. If engine speed's above, that's less than 500 RPMs. So now if coolant temp gets over 225 degrees and engine speed's above 500 RPM, this warning will trigger. And you can select if the left LED on the screen will come on or the right LED will come on. And I'm gonna select left because this is just a warning. I'm gonna create a second one. I'm gonna call it alarm coolant temp. This is when things get really bad. Same deal. I'm gonna select coolant temp as my input channel. I'm gonna select the minimum temperature. If the coolant temp gets above 235, which is pretty bad, add a second line to that. Leave the logic as and. I'm gonna set engine speed as a secondary channel that it must also meet. And if engine speed's above 500 RPM as well, this will trigger the coolant temp alarm. I'll probably name this something better. Let's see. And then from there, this will just trigger the LEDs. I can have it trigger right LED, left LED, depending on how bad it is. But we're gonna go beyond that and create a warning message. Right now I have warning messages for battery volts and oil pressure. We're gonna add another warning. We're gonna select our current warning that we just created for coolant temp. And then we're gonna create a simple message to display. We're gonna say warning, or we're gonna say coolant temp high. The @ sign lets us bring in a channel. So it's not just gonna say coolant temp high, it's gonna say coolant temp high at this temperature. And then we're gonna put Fahrenheit, it's just degrees F. And then we'll select the channel that's gonna drive that warning number that's gonna let you know what the temperature is. And the label input format just lets you denote how many digits are there. We're gonna do 3 digits. The pound sign lets the dash know that that's a optional number, optional digit, and then the 9 tells it that it's a required digit. So now if the temperatures get too high, we're gonna get a little message across the bottom of the screen that'll let us know, and we can test that on the simulator. And then we're gonna select engine speed, change this to 1000 RPM, and then we'll go and check coolant temp. We'll set this to 227. And now it says coolant temp high, battery volts low. So all the warnings will come up if the temperatures get over 220. I can check it. So that should be good. And then we can also create an alarm message, same deal. We'll bring in our coolant temp, our alarm coolant temp high. Same deal, coolant temp high, @ sign, degrees F. And select a coolant temp channel to drive this message. And since this is 3 digits on temperature, pound sign twice, and then number 9. And then what we can do with this alarm message is drive an alarm screen. So this will come up if it gets too hot, when things get really bad. And we'll just go to the checkbox for alarm triggers. And we'll select our alarm coolant temp high. So now that this page will look that if that alarm gets triggered, it'll show this page. And that's pretty much it. As you add more channels, it changes the rates, it'll update that. And then I have it set for loop logging.
Hey guys, what's going
Hey,
on?
Chris, how you doing, man?
Nice to meet you. Nice to meet you. What's going on?
Good thing you came here. I mean, we're just finishing up here, and you got Sam from AEM to walk you through everything.
Love when a plan comes together. Okay, yeah, walk me through, please.
All right, Chris, let's go over what we did here. I set you up with the boot up page. So this is the page you'll just see when it first starts up. It kind of lets you get a good sensor check, make sure everything's up to temp before you hit the track.
Okay.
When everything's all good, you hit this the page change button, and it'll take you to the first driving page. It's very simple. You have your fuel level, you have your speed, your tach, and engine vitals. This is where you'd be driving. And the beauty of the dash is that you don't have to be looking at it. That's the great thing about it. Yeah. When there's something wrong, a little warning message is going to pop up at the bottom here. I have it set for if coolant temp gets too high, it'll let you know. If oil temp gets too low, it'll let you know. If your battery volts gets too low, it'll let you know as well.
Oh, that's key.
And then if things get really bad, I have another level which will show a full-on red screen if your coolant temps gets over 235 degrees, which is really bad.
Okay.
Second page is the second driver page. Kind of same layout, but this has your lap timing information. It shows your current lap, which lap was your fastest lap, and where you are compared to your fastest lap. It'll let you know if you're going faster or slower by how many seconds to compare to your fastest lap.
Oh man, show. Christmas comes early this year, then. Sweet.
And then the final page is purely just lap timing. So if you want to focus on just your laps, it'll show your fastest lap, your predicted lap, your current running time, and your last lap time.
Sweet.
So.
Okay. Do I need to upload track layouts, track
No.
track maps to this?
The lap timing is done via this purple wire. Basically, that needs to go wired to a momentary switch to ground.
Okay.
As you're driving on track and you come across a start finish, you hold that button down for 3 seconds.
Okay.
The dash will light up and let you know that it has set that point as the start stop.
Finish. Okay.
So it basically draws a perpendicular line to your current heading 50 meters across. So as next time you come back around, that same spot, it'll update your lap time as well.
Oh, okay. I could do that. That's in my wheelhouse. I could do that.
Yeah.
Okay.
So in your like warm-up lap, you just go around, start, finish, hold that button, and then next time you're going, you're good.
Oh, sweet. Man, this is easy. Okay. All right.
And then when you want to go and download the logs, it's all done through this connector. You can mount this somewhere nice and easy to access.
All right.
And you just use our AEM data software. You plug into it, it'll say that it'll detect the CD-5, and it'll tell that, okay, there's logs available on it. You just click download, and you're done.
Now I'll be able to see my my temperatures, all that data will be logged, and I'll be able to, at a later time, pull up and see, okay, on this lap, I ran this hot, or this lap, my wideband, my AFRs were this measure. I can see all that.
Yep, and you can get as simple as you want or as complicated as you want. I have a bunch of templates, and one I use when I do a lot of the support for the Trans Am class. Let's see. Let's open up a log here just to give you an example of what you can do with AEM data. So I do a lot of channel reporting because I'm out there. I'm supporting like 30 plus cars, and I can't spend a ton of time on one car. But I do this simple engine vitals that shows me my like average oil pressure over RPM through the entire session. So I'm seeing any dips. If I see any dips anywhere, I can click on that one dot, and it'll take me to that certain spot in the log where it happened, and I can see it on GPS and let me know, okay, I was in this corner, I had the oil pressure dipped. Okay, maybe I addressed my oil pickup or something like that.
Okay.
So, you can get really crazy with it like this,
Yeah.
or you can just simple graph and scroll through and see what you want to do with it. But
Man, okay. That's awesome. Like, I love the fact that it still has the warning feature, because that's what I had with my AEM, the X Series gauges. Like, that was a big help to me. I before I got those X Series gauges, I had another brand, and they were good, but it just cut down on my distraction. Yeah, exactly. And for me, like, I drive on the aggressive side, I would say. You may have seen like some button willow and willow springs crumbs in here. So I need to focus on the task at hand. So with those gauges, they were nice, but then I'm looking over at my A pillar for the gauges, and I'm looking at my OEM tachometer for the stuff here. Then I got gauges over here, and then I got my lap time right here. So I'm just like all of them. Then I got black flags flying everywhere. So I'm just like, with this, like, it lets me be able just to focus in like all the stuff that I need that's vital to me in mid lap. Like, it's right here. Like, that's gonna be awesome.
And that's a point I bring across a lot. You got two kind of drivers. You got your ones that are really fast but don't care about what's going on in the car at all. And you guys got guys who care way too much about what's going on in the car, and it hurts them in their time.
Yeah.
So this takes that all out of the picture. The driver could just focus on driving, don't do anything until this thing tells you to.
Oh, yeah. Sorry, this is perfect. Yeah, sign me up. I'm sold. Yeah.
All right, well, hope you enjoy it, Chris.
No. Thank you so much. I appreciate it.
I love your work. It's awesome. It's everything I wanted and more. Like, I can't say it enough. Like, that's perfect for what I'm gonna do with it.
So now that you went inside, got to play with it a little bit and get a feel and get a little bit of look, what's your initial impression?
My initial impression is I can't wait to get this thing on track and to get a hot lap going. Like, not having to worry about all of the distractions I used to have in the car before and being in different spots. Like, they're all right here. They're all right in front of me. And I don't necessarily have to watch that all the time. There's warning displays that are going to pop up and let me know what's going on with the car if need be. Like, that is perfect. The mount, the install, like, everything is right where I want it and right where it needs to be. Like, to let me focus on the lap and try to keep this thing on a paved road and not in the dirt.
So what do you think of the display size and the readability of it?
It's very, after the small tutorial that I got, it seems very user-friendly. Like, I thought going in that this is going to be something that I was going to have someone set up for me and then not touch it, but this is extremely user friendly. Like I was very, very surprised at how like crisp friendly this thing is going to be. Like I can get through these menus, I can change them very quickly on the fly, and get to what I want to super easy. Yeah.
So why don't you take it for a spin and tell us what you think?
Oh, you read my mind.
All right.
Oh, do your outro. Now do your outro. Stay right there and do your outro.
Shit, I forgot what my
Say,
outro.
while he does that, go to, if you want us to do anything in your car, go to.
Oh, okay. So while Chris goes for a spin, if you need any work done on your car, go to MotoIQ.com, go to the MotoIQ garage link, give it a click, fill out the form, and we'll get back to you, and we'll do whatever you want within reason.